Okay, I'm going to have to do this quickly because I'm running low on battery. So what we're going to look at here, this is the last page, is the segment rules. Now remember the segment rules, okay? If you have two chords that intersect, piece times piece equals piece, sorry, that's kind of times piece. You multiply piece times piece. So do I have two chords intersecting here? Yes, I do. I didn't write it out that great. So piece times piece. The blue chord is right here. Everybody see that? So 6 times 2, the two pieces of the blue chord, are going to equal x times 3, which is the two pieces of the red chord. Does everyone see that? Sure you do, because you can't answer me. So what I'm going to do now is I'm going to multiply 6 times 2 is 12 equals 3x, and I'm going to divide both sides by 3, so x is 4. Now if you want to check your answer, is 4 times 3 equal to 6 times 2? Yes. Remember, with chords, it's piece times piece equals piece times piece. When you have two chords, remember, chords are segments whose endpoints are on the circle. They don't go outside the circle. Okay? So that is for chords. All right? Let's look down here. These are not chords. What are these? These are secants. Okay? They're secants. Secants are different. Secants follow the following pattern. Okay? Secants equals whole times outside equals whole times outside. I'm sorry, I'm running out of room here. This is not the best rendition of it. So secants, whole times outside equals whole times outside. So let's look at this secant. Remember, a secant passes through the circle twice. Do you see the difference between a secant and a chord? The chord stops on the circle. The secant just goes right on through, keeps on trucking. What is the entire secant here? X plus 10, right? That's whole. What's the outside piece? 10. That's the red secant. Let's look at the green secant. Let's use Grinch colors. What's the entire secant here? 8 plus 8, which is 16. That's the whole secant. And what's the outside part? Times 8. So I just solved this out now. I'm going to distribute x times 10 is 10x. 10 times 10 is 100. 16 times 8 is 108. Okay. 16 times 8 is 108, I believe. 80 and, or sorry, 128, because I'm a math teacher, you know. So 80 and 48, 128. So I'm going to subtract 100 from both sides. So 10x equals 28. So I'm going to divide both sides by 10. So x equals 2.8. Now, if you want to check and see if you did this right, what you can do, I got to hurry up, I'm about to run out of battery here, is let's check it. If I put 2.8 in there, is 2.8 plus 10 times 10 equal to 16 times 8? So 12.8 times 10 is 128, and 16 times 8 is 128. So yes, that's the correct answer, is 2.8. Again, chords, piece times piece equals piece times piece. Okay? Secants, whole times outside equals whole times outside. And then our last one we get into is tangents. And I'm trying to do this before the thing runs out. When you have a tangent and a secant, okay, whole times outside for your secant equals tangent squared. So let's look at our secant. What's the whole secant? 4 plus x. What's the outside portion of the secant? 4. Right? Equals, and this is a tangent. It's not a secant. So what I'm going to do is I'm going to square it. Tangents are squared. Whole times outside for the secant equals the tangent squared. So I've got to distribute here. 4 times 4 is 16, plus 4x equals 64. I'm going to subtract 16 from both sides, so 4x, excuse me, equals 48. I'm going to divide both sides by 4, so x is equal to 12. If you want to check your answer out, what's 4 plus 12? 16, right? So is 4 times 16, outside times whole, equal to 8 squared? And the answer is yes, they're both equal to 64. So that's how you use the special segments in triangles.